12.8 coordinate proofs. So a coordinate proof involves placing geometric figures, so squares, rectangles, triangles, so geometric figures, in the coordinate plane. Now, the reason we're going to be doing this is because when we place a figure in the coordinate plane, we can prove things. We can prove side lengths, we can show things, and when you prove something in a geometric proof, it then holds true for all figures who are congruent to it. Example 1, placing a figure in the coordinate plane. So, place each figure in a coordinate plane in a way that is convenient for finding side lengths. And the key here is convenient. And then assign the coordinates to each vertex. So we want to take in part A a rectangle and place it in the coordinate plane so that it's easy to find the side lengths. So if I were to take a rectangle and stick it right here, that might not be the best option, because then I'd have to go negative something, positive something, and that would require a little bit more math. You could do it, but it's not as easy. So a more convenient way is usually we like to use the origin. Place one of your vertices of your rectangle at the origin, and then from the origin we're going to travel up the y-axis, over the x-axis, and we're going to place our rectangle right there. Now, in order to find the distance, if you're trying to find the distance here of our bottom, well, however far out this is, let's say this is sitting out here at 10, well then I know that the distance here is 10. But for the sake of a coordinate proof, we don't assign numbers, we assign variables. So let's say that this is the base, so I'm going to say that this has a length of b, which means if this is over here at 0, 0, our origin, then this is going to be out here at b, comma 0. And again, that could be like 10, 0, 5, 0, however long the base of our rectangle is. Now, let's say over here that this is the height of our rectangle, which means that it goes up to 0, h. So those are its coordinates. So then the last thing we have to figure out is, well, okay, well then where is this guy? Well, that guy, remember when you plot a point, you come over, and we're coming over b, and then you're going up, and we're going up h. So this guy is at b, comma h. Part B, a scalene triangle. Now, keep in mind that a scalene triangle is a triangle with 3 different side lengths. Okay, and again, if it's going to be convenient for finding side lengths, we probably want to take one of the vertices and put it down there at the origin. Now, I'm going to make my first side kind of short, my next side kind of longer, which means my base side is going to be the longest. So that's my scalene triangle. Now, once again, we have to assign coordinates to our vertices. So our first one is simply at the origin, which is 0, 0. Then when I come over here, I get to pick whatever distance this is. So let's call this, we could call it the base again. So this would still be at b, 0. Now this point up here gets a little more complicated, because if I'm trying to find that point, I have to come over this much and up this much. So if I'm going up, that to me is kind of like the height. So I'm going to go up h, but how far over am I going to go? Well, according to my picture, I go over a little bit, so let's just assign that a. It's not the full length of b, so we could just call it a, which means I'm going to give this guy the coordinates of a, h. And honestly, the letters you're using here don't matter so much as long as you're putting your zeros, like a 0 here, in the correct places. Letter C. Show another way to place the rectangle from above that is convenient for finding side lengths, and assign new coordinates. So last time I kind of laid my rectangle down. What if we were to stand him up? So I'm still going to stay at the origin, but this time I'm going to make him a little taller. Okay? And then the other thing is when we're placing something in the coordinate plane, if it's going to be convenient, it's always good to keep it in the first quadrant because numbers in the first quadrant are positive. You don't want to go negative if you don't have to. So this guy is still at the origin. This guy, let's say he's out here at H. Oops. So he's out here H long. And then let's say this guy is up here at K. And remember, a y-intercept is always 0 something, and x-intercept is always something 0, which means that this guy now had to go over to H and up to K, so this guy is going to be at HK. Letter D, a square has vertices. Okay, square has vertices at 0, 0, M0. So M0 is just telling me that it's somewhere on the x-axis. So this is 0, 0. This is M0. I don't know how far M is. I just know it's out M long. And 0M. So again, I don't know how long M is, but I do know that M over here and M over here are going to be congruent, especially because I know that this is a square. Find the fourth vertex. Well, if it's a square, I know what a square looks like, and I know that it has congruent sides, which means my fourth vertex has to be over there. So if I go over M and I go up M, then I know this guy is at M.